what we did, there are two methods what we talk about. One is the I call direct method, MRS equal ERS. So there are point A is the optimal point and demand for two goods, X and Y. We discuss. So taking this optimal level, that is the demand, and we derive the Marshallian demand function. The other method, because that is the original we had to do, because this is, we play with the constraint optimization, the Lagrangian method. The Lagrangian method, we can apply both cases. The minimum maximization of utility given a budget constraint, and also minimization of expenditure subject to given utility. Yeah, the Lagrangian method, if you use, for example, if you take as objective the maximize utility subject to budget constraint. Let's say utility function, the simple one, X and Y. So how to write Lagrangian X, Y, then add the constraint so that how the right Lagrangian. With that, the first order condition, what we have to do first, differentiate with unknown variable here. So with X with respect Y and with respect lambda. The first order condition, we set them equal to answers equal to 0. We get the T equation. When you differentiate with respect X here, what you get here, Y minus Px, here X minus Py, here Px, X, Py, Y minus M. With these three, the equation, what we did, we derived the Marshallian demand function, so that X function of P and M, and also Y, the function of P and M. if you remember this particular example, we get the Marshallian demand M divided by 2P for Y, the demand M divided by 2PY. So that thing we call the Marshallian demand. Marshallian demand function. Now, what else we did last time? Given the prices, given parameter, for example, money income, let's say amount 100, price of X, let's say $4, the price of Y, let's say $5. This given income or the given parameter, we estimate how much you buy from X and Y. And Y. And you can calculate here, for example, from X, 100 divided by 2 multiplied 4, coming 12.5. That is the demand for it is given. And the Y also you can find how much you buy. So we already did. And next what we did, change in this parameter, for example, constraint change and the shock, I like to it. Tax, for example, introduce direct tax. Let's say now reality 36% and tax. What happened? And then again we did direct tax, indirect tax, 50% introduced. Such a way we managed to get. And look at here, roughly now Sri Lanka is 36% and around 50% tax case. Yeah, 50% tax case. Usually we pay 86% of tax to the government. That's a different thing. You can see how much we pay to tax. If you earn 1,000 rupees, 860 goes to government. We have left only 142 for our. So that's that. We have to look at the bad thing, the government policy. Now we did this one, and also today I tried to introduce a new thing. Of course, not new, and that we call minimum value and maximum value function. Now, for example, what we did, the maximization, the objective, utility maximization, we'll take a utility function as usual, what you took, and subject to the budget constraint. There we can derive the maximum value function. The other thing what we did, duality, the minimize cost or budget, to minimize expenditure, subject to given utility, given amount of utility. Now, if you take this one, the maximization utility, and we did Lagrangian x, y, we already did last time, -1. And today also I did. Now after that, first order condition, for the first order condition, first differentiate with Lagrangian with respect x, y, and lambda. When you differentiate with respect to x, you get the y. Minus px equal to 0. That becomes the first equation. Second, with differentiation with respect to y, we get the x minus lambda py equal to 0. And second equation. And the third, with respect lambda, we get again the budget constraint like. And third equation. From where we got the answers to x, that's the optimal value. If you visualize this optimal value, of course, we have the result we got here, m divided by 2px and m divided by 2py. So those optimal value, what we have, using this optimal value and plug into this objective function. Our objective function is the utility. Then this objective function becomes the optimal value. That's what we call maximum value function. The x, now we use the optimal value, that means x star, y also y. Here I did relative transformation. Instead of y, u, I convert as the v. V stand for indirect utility function. So what I try to get is here, the indirect utility function, but it's called also the maximum value function. Now for x, now we already found the answers. M divided by 2px. My, now m divided by 2py. With this, we get the maximum value utility function or indirect utility function. For px py. So this function we call this function we call indirect utility function. Now our indirect utility function, now example, now here since it's a duality, this indirect utility function you can convert into minimum value expenditure function. You can convert into minimum value expenditure function. But if it changes what we do, here we get left hand side, we take the other side. Now in that transformation, what happened? M V O X Y P X P Y. Now a small change I'll do here for V. Since it's identical, I convert as a U, convert as E, because the money income equal somebody. Okay. As the money income equal expenditure, so this become E. Then what we have? O U P X P Y. So the E become O U P X P Y. This function, what we call minimum value expenditure function. Now we will derive two functions, direct utility function, the minimum value expenditure function. What we did is, either way also you can do, later on I'll show you. Either way, mean first derive the expenditure function, this convert into utility function. We can do, since we are playing with the duality in the sense maximization and minimization, we got the same result. So it no matter we can do. Now, one more thing. Now take the utility function we already had, direct utility function. You saw that it's a function of price and the money, but you get the value m power 4 px py. So this, from this differentiate the parameters, we can derive the Marshallian demand function. I'm going to do how to get the Marshallian demand function from this. That exercise what we call Roy identity. Roy identity. What is Roy identity? You differentiate the indirect utility function with respect relevant parameter to derive the demand function. For example, x, price of x, then divide by the income effect, differentiate with respect money income. So there you get the answer. That answer we call the Marshallian demand function. Now what you have to do, this already you have this direct utility function. Do this differentiation and then you can get the answer. Of course, answer what you get. When you differentiate and do this exercise, divide by 2 px 2px. So that is the Marshallian demand for x. Similarly, the Roy identity we use to derive the Marshallian demand function for y, you have to differentiate with respect py and divide by the differentiation you do with respect to m. So that you derive demand for y. Answer, of course, when you do really differentiate this one, when you differentiate this one, answer you get m divided m divide 2 p y. This the Marshallian demand function you get doing the Roy identity. So that is the second exercise we do. Now we already derived from here expenditure function, minimum value expenditure function. So what we got is for px, py, u. From there, we can derive differentiation with respect parameters. Now, expenditure function, we differentiate with respect px, you get another equation that I use the x hat. There you get the function of price and u. That function we call Hessian demand function. Hessian demand function. Or we call another name the compensated demand function. Hessian or compensated demand function. Hessian demand function. Or another name why we use compensated demand function. So I will show you later on how to graphically, then visualize, you can see, then you can understand. Now this is the Hessian demand function for x. Hessian demand function. When you differentiate, you get the, of course, the answer. I hope you have done already. The answer, when you differentiate with respect, what you get, the P y u divided by px. Likewise, Hessian demand function for x, that's what we have to differentiate E with respect py. There you get the answer px divided by py. So these two functions are called Hessian demand function. This process, what we do to get Hessian demand function, the process means after you had a minimum value expenditure function, from there how to get this Hessian demand function. This exercise, what we call, now previous one we call ROI identity. This exercise we call Shepard lemma. separate lemma. Separate. In other words, separate lemma mean if the mathematics shepherd is the name of the mathematician and the mathematical exercise, if you differentiate the minimum value function with respect to its parameters, we call shepherd lemma. It is economics, theory of consumer behavior, expenditure function, minimum value expenditure function. If you differentiate with respect to its parameter, that is shepherd lemma, we get Hicksian demand function. Now, the point here, reality, you collect the data, the real well, the consumer's expenditure, and you estimate the, suppose you estimate this direct utility function and expenditure function. Yeah, then you can derive Hicksian demand function and the Marshallian demand function. The Marshallian demand function using indirect utility function, the method Roy identity we derive. The Marshallian demand function, the difference between the Marshallian demand function and Hicksian demand function, the Marshallian demand function captures total price effect. The Marshallian demand function captures total price effect. Which, component, substitution effect, the Hicksian demand function only captures the substitution effect. Hicksian demand function only captures the substitution effect. So only Hicksian demand. I hope you understood. Soon I will show you how to get it. And the exam, you may ask to do the Roy identity and derive the Marshallian demand and convert expenditure function and do the separate lemma and derive Hicksian demand function. Another thing, directly you can derive the minimum value expenditure function this one what we had here. Directly we can get it also. That what we have to do the exercise, expenditure minimization. Minimum value, minimize objective is the cost minimization or expenditure minimization. Subject to the budget constraint. So there also you write the Lagrangian. The objective function X plus py y. Then at the constraint, that is the utility, but you get the example xy, very simple utility function. So there, again, the first order condition. Again, the first order condition. You differentiate with respect x, with respect y, and with respect lambda. When you differentiate with respect x, you get the px minus lambda y equals 0. That's the first equation. Similarly, differentiate with respect y, py minus x equals 0. Second equation. The last one with respect lambda, then you get the y u minus xy equals 0. That is the third equation. Now this equation again, you get x hat, the optimal value, and y hat, optimal value. So here, definitely you get for x, py, u, px, y, you get px, u divided by py, these two are the one you get the optimal value with minimal process. If you plug this to expenditure function, what is the expenditure function? P x x. Now we p x hat declared py y hat. You get the expenditure function, which means the px here, py u px plus py px u to simplify this one, I'll do here. And then the expenditure function you get the function of p and u to px py u power up. So this expenditure function directly you can get. In the exam, if I ask you to derive the first expenditure function, the minimum value, then from here you can convert and you can get the indirect utility function. Indirect utility function. Then definitely you get 10 power 4 px py this indirect. By the way, you can do that. What I want to show you. Do you have any clarification, any questions, anything? So what I did here today, derive the minimum value expenditure function, the maximum value utility function or indirect utility function. They are doing ROI identity, the Marshallian demand function, and the separate lemma we derive Hessian or compensated demand function. So that's only I did right now. Any question, any clarification, you can ask me right now. So any question or any clarification? Okay. Look like no. Now we'll show you graphically. I'll show you how graphically derive this Marshallian and Hicksian demand function. Marshallian and Hicksian demand function. Then you will understand more. Yeah. Now, when I draw here, if you draw, keep some space down also to draw some other curve, like here. Now let's say this is two goods. Consider, let's say our good is X. So this also we can put X. This vertical axis, all the other money income, all the other goods we can put, no problem. Let's say the original situation like this. Original situation. Let's start with that. And let's say this is, let's say money income constant plus 100. The price of Y also constant. Let's say this is the price of X. Situation $4. The first curve is the price of X $4. Now the second, let's say shock upon the price of X decrease up to $2. Now we can look at the situation if other thing constant. Okay, the budget line goes like this. And the consumers can reach higher indifference curve, let's say I2, and originally the optimal bundle A. Now let's say B. So we know how consumers move. Now, second shock will say X increase up to $5. So the price increase up to $5. The budget line rotate clockwise and reach somewhere here. With the result, the consumers can approach effort A or B. They settle down somewhere here and only reach indifference curve T, lower amount of utility, and settle down point C. Now you can see, if you put some figures with the price of X $4, let's say consumer buy from X 50 unit. If the price goes down due to both effect substitution and income effect, increase buy from X, let's say increase up to $7. A price increase up to $5, reduce consumption due to again the substitution and income effect, let's say drop up to 40. Now, this movement, the optimal point, connecting, if you draw a line like that, that line we call PCC, stand price consumption curve. We used another word, price consumption path also. Price consumption curves show the direction the optimal, the consumer, personal consumers move, the optimal point. Using this PPC, we can derive another curve. So what I'm going to do, look at the different prices. Here, this curve, let's say $2, $4, and the $5. Now look at with the $4, $2, this consumer buy 70 from X. 70, $2. We can find point B. Point B, we have got that. Now, if you look at the point A with the $4, if unit buy from X with the $4, there we can find the point. When the price increase up to $5, now consumer buy only 40 unit from X. So then the $5 we can find the point C here. Connecting this ABC, if you draw a line what we call the Marshallian demand function. What we call Marshallian demand function. You can see here, total price effect. Total price effect. Now, like I said, I mentioned already the Hessian demand only substitute effect. We need a different technique to derive here. I will show quickly. So if you understand this one, then I can move that. I hope you got it how to derive. Again, I will do anyway, how to derive the Marshallian demand curve and which captures total price effect. Okay, look like no question. Now look at, we did another thing also. If see there's a constraint total income, the money income in the entire budget line shift like that. The entire budget line shift. And the consumers also reach to different indifference curve or level of satisfaction like this. The move point A, B, and C like that. This happens when the income increase. So connect these lines, we can draw another curve that we name as a ICC, International Cricket Council. So this is not International Cricket Council, this is income consumption curve. So income consumption path or income consumption curve. So income consumption curve. From this income consumption curve, we can derive another demand curve. I will show it that. For this, I need another graph underneath. Here. Let's say this is different income. Here, let's say $100. Here, 120. Let's say $150. Different income and $100. This axis here is money income. Is X good? It's also X. 120. And then let's say here 150. Now with $100, this particular consumer buy from X, let's say 50 unit. When the money income increase up to 120, it's increased by, let's say, up to 70. Likewise, money income increase up to 150, let's say he buy 100 unit. Now the point, find a point here, we go down the 50. And this is $100 budget. Here you can find the point A. Likewise, with $120, the consumer buy 70. So that's point B you can find here. Likewise, $150 budget. He buy 120 unit. So $150 point C point here. Connect this ABC line. We derive another demand curve. That demand curve we call angle demand curve, which capture the relationship between the money income and quantity of demand. So the angle is the Russian economics. He is the one who gets that angle demand curve. Now slope and shape of the angle demand curve depend on ICC, International Cricket Council. Now we can see, we learned previously, if the angle demand curves like this, when the money income increase, demand also increase, that type of good we consider as the normal. The elasticity is greater than 1 luxury good. And still, angle demand curve has a positive slope, but the plateau then we consider as normal good. If the negative slope angle demand curve if you get, we consider as and inferior good. So we already discussed those things, and we will see later on how we use indifference curve analysis to derive those Engels curves for different goods. Any questions? Any clarification? Any questions or any clarification? Good. Okay. Still, I did not show you how to derive graphically compensated or Heckian demand curve. We'll show it soon. Before that, I'll give you a 5-minute break. So after that, I'll show this what I did right now in the whiteboard using PowerPoint presentation. I will continue. So the 5-minute break I can take. After that, I will continue. What we discussed last time and also today, the equilibrium and the optimal the optimal solution of what we got. Now, this is the point today I discussed to in the constraint. So there are two constraints what we have, the income and the second one, prices. I'll start with the change in income. When the change in income in expenditure or the budget line shift, and through this exercise, we derive two curves. The one is the income consumption curve. The other one, the Engel curve. So when the income change, the consumers move like this and settle down, and the move along ICC, like I said before, not the International Cricket Council, income consumption curve, the consumers move. So in other words, income consumption curves the line. We take all the equilibrium point when taking the income change, keeping the prices constant. From this income consumption curve, we derive the Engel curve. So that the relationship between money income and demand, quantity of demand. Now here, if you take the normal goods, this is the income consumption curve and the income change at the positive slope. From ICC, you can get the Engel curve that is also positive slope. Now, if you take an inferior good, the ICC, you get the shape, it has negative slope, and it creates the Engel demand curve. It also has the negative slope. So that's what we already discussed. And one more thing, now I need from you to get the Engel demand, sorry, ICC, this shape a different budget line. Let's say these are different budget line. And I indifference curve. With the ICC, good. Now, can you draw the angle demand curve and try to identify what type of goods? So different money income with the budget line. Quickly derive the angle demand curve. And tell it's what type of good. So nobody send me what you have done. You practice later on. What we did here, the equal demand curve for an inferior good. The second constraint, change in prices. Here we derive two type of curves. The one is the PCC. It look like a Pakistan cricket board. That is the price consumption curve. The other one we derive the demand curve. We call this as the Marshallian demand curve. The Marshallian demand curve. How we graphically do it is the price change. For example, this happened for X, and the consumers, the equilibrium set different point, and connecting those, the equilibrium point, we get the price consumption curve. From the price consumption curve, we derive the demand curve. That demand curve we call as the Marshallian demand curve. Usually, the Marshallian demand curve, according to the law of demand, has a negative relationship, but there are some exceptional cases and it's called Giffen paradox. So we will see how the Marshallian demand curve shape and derive for different type of goods. Now here, it's a normal good. So what happened with the price change? And we got the price consumption curve. From the price consumption curve, for example, here the PX1 and the PX2 and a different demand. With that different demand, we get the curve. With that curve, we call the Marshallian demand curve or Marshallian demand function. So that is a normal and the negative slope also. We got it. And the Giffen good, we call Giffen paradox. The price consumption curve, we get like this. The price goes down, price reduce. So they are the demand curve we derive. It has positive slope, which means the price increase, demand increase. So opposite of the law of demand. So reasons for this, the Giffen goods is a special kind of inferior goods, a special kind of inferior good. To understand the real Giffen paradox or Giffen good, you have to break this total effects into substitution effect and income effect. Oh, you have to understand the decomposition of the price effect into substitution effect and income effect. Now, like I mentioned before, the Marshallian demand curve capture total price effect between the both substitution and income effect. The Hessian demand curve, like I already mentioned, capture only the substitution effect. Single demand curve capture income effect. Now we can see the differences of the different demand curves. Now first we will see how to do this decomposition. And so first the whiteboard, then leave some space down if you draw with me. I know maybe most of you are not with me, though it's online. Now here, let's say the original situation. And here good X. Maybe you can name here whatever, other money income or other goods, whatever. Let's take the original the equilibrium point with the indifference curve on original budget line I name as the one. Let's say, so this is the point A, the original situation. Now what happened if the price of X decrease, new budget line, the rotate anti-clockwise, you get a new budget line I name as 2. The consumers will able to reach another level of satisfaction let's say point B. Now here A to B movement, let's say here demand from X50 after price reduce, let's say demand increase up to 100. Original price is say price of X and the new price less than that price of 1. So here the demand 100 from X, here 50 like. So this 50 to 100 increase the demand we call as the total the price effect. Total price effect. Now total price effect has 2 components, substitution effect and the income effect. Now I try to single out, decompose these two effects, and if you capture like we already did, only the total effect without decomposition, so decide the price of X. Now let's say the lower price, that's the PX1, so PX0, let's say the PX0 is $4, PX1 is $6. The $4, we show the demand is 100, and we get the point B here. $6, when the price increase, let's say somewhere here.
Professor, PX0 is larger than PX1, right?
Oh, sorry. Yeah, this is the $4. With the $4, the price, it has to be $4. $4 is $6. Thanks. Now the $6, particular consumer demand from X, only 50. And we got the point A. Connect this to A and B point. We derive or we draw the demand curve. That's the demand curve we name as the Marshallian demand curve. So you can see it captured total effect. Now the total effect has two components, substitution effect and income effect. Now we see how to capture substitution effect and derive the Fixian demand curve. So that we have to draw another budget line. We got third budget line. That third budget line, what we call, the textbook also call hypothetical budget line, which two things must happen. Parallel to the new budget line and touches the original indifference curve. So I draw here. So you can see the parallel to the origin, the second new budget line. That touches here at this point, somewhere here. I mark as the point C. Original indifference curve. Now we remember the indifference curve. If you draw like this indifference curve, the slope of the indifference curve or move along the indifference curve is about the substitution. Here the slope, MRS, marginal rate of substitution. So you can see A to C in that case, about substitution, move along the same indifference curve. Now, which means this capture A to C here, let's say here 70, this consumer increased demand from X, additional 20 due to substitution effect. Now only capture the substitution effect when the price reduces up to 4. The point C we can find here. To capture this substitution effect, if you draw a line here, that line we call Hessian demand curve. You can see it's a capture only substitution effect. Now you can see the difference between the Hessian and the Marshallian demand curve. Now later, when you do exercise, you can see yourself, always Hessian demand curve has a negative slope. Never get the positive slope Hessian demand curve. That is the compensated, which means when the price change is about to compensate and from other good to the other. But the Marshallian demand curve could be positive slope and negative slope. Depend on in that way due to income effect. Now here, this particular example, income effect also positive, that is 30. Both the same positive reaction, the normal good. Now in period good, you know, the income effect is negative effect. Normal in period good, in fact, income effect has negative. Income effect is negative, but the negative income effect less than positive substitution effect. Normal period good, what we consider. Now, this particular example, both positive, that is the normal good. If you look at inferior good, income effect negative, but let's say income effect due to income effect, consumer reduced consumption 10 unit. But due to substitution effect, consumption increased 30 unit. Here, reduction, here adding. Now, different paradox, that's a special inferior good, negative income effect, negative income is greater than substitution effect. Let's say the negative income effect, 30 unit, you reduce the consumption, the positive in substitution effect only increase 10 units. Because of that, you get Marshallian demand curve with positive slope Marshallian demand curve. So you will understand when I show PowerPoint slide further. Now here, third curve, also I'm going to draw down here. That is the angle curve, same good X, here X. Here I use the money income. Now look at the, look at the second and third, the budget line. Second and third budget line. Third budget line with the low income, let's say somewhere income M1. Second budget line with the little high income. That's why the budget line go. Let's say here income level 100. Income level 100. Here let's say 80. Now look, say 80 income level, the consumption is 70. They are captured the point C. When income increase up to 100, the demand increase also up here, in this case 100. you find point B. To connect those C and B, if you draw a line, that is what we call angle demand curve. Now you see, we draw the Marshallian demand curve, we draw the Hessian demand curve, we got the angle demand curve. Now here, the Marshallian demand curve, it could be the negative slope, it could be positive slope. Angle demand curve also same, could be negative and positive slope. But the Hessian demand curve always has a negative slope. Don't forget those things. And those normal in period and Giffen group paradox also this argument valid. So with that, I better stop today. The quickly again I saw this decomposition, and next week I will start from this point anyway. Now look at here what I discussed right now with the support of whiteboard. Now the original consumer point E1, when the price of X reduced, the consumer leave to the green color budget line. And with that support, we develop the hypothetical budget line, that is the red budget line here. So that capture substitution effect move along the indifference curve. X1 to X3 increase the consumption, that is substitution effect. So capture substitution effect, we draw demand curve that is compensated. So the income effect, you see the green budget line and red E to E2 movement, income effect. So the total effects, now you can see the two. To understand these two effects, income and substitution effect, there are two methods, Slutsky and Hessian method. So next week I will introduce these two methods, how to identify substitution effect and income effect. With that, I'll stop. If you have any questions, you can ask me. Otherwise, you can leave the meeting. Also, I also leave the meeting in 2 minutes. Okay, it look like no question. Then thank you.
Sir, regarding the assignment.
Yeah.
Yes. Sir, we have submitted the abstract. Sir, we have submitted the abstract. Is it okay if we start the assignment, or do we have to?
Yeah. Because I reply, but I wanted to tell you also. I checked the LMS also. Only few submitted. I want to give the list today. I forgot it. Next week, definitely I tell. If your name is not there, then you have to resend me, and you can do. Even you can completely change it, and you can start and you have to submit before the deadline. That we have to do. You don't need to ask me, and you can completely change. Now today, what I noticed that some of the areas, like for example, nowadays people play with the social media, Facebook and things. You can do a very good study, different age group, different gender and different occupation, how expand social media and how it's cost to the family, cost to the society, because some of the people, youth or maybe some of the people, 2-3 hours per day spend in the social media. Those are the new areas with the digital world, and you can do new research also. No problem. You can start and you can do. I need only before the deadline. After deadline, if you submit, I deduct marks. Even I don't tell you, but I deduct marks.
Okay, sir. Thank you.
Thanks. Bye-bye.